Alright, ladies and gentlemen, welcome back to another video with Mr. Kenton, your favorite physical science teacher. Well, it's because I'm your only physical science teacher, but hey, I'm still your favorite. Thank you guys for tuning in. This is a continuation of our video from last time where we introduced chemistry. And in our last video, we ended by looking at this flow chart that talked about the different types of matter. We had pure substances and mixtures, elements, compounds, homogeneous mixtures, and heterogeneous mixtures. And so today, my task is going to be breaking down each of those different types of matter and giving you a good explanation as to what they are. At least that's my hope. Hopefully I can accomplish that by the end of this video. Are you guys ready? I know I am. Let's get to it. So, pure substances. We're going to start on that left-hand side. And so if you remember, your pure substances are those types of matter that are made up of one type of substance. And by definition, a pure substance is any substance that cannot be separated into smaller components by physical methods. Now, when I say that, you might be thinking to yourself, Mr. Kenton, what do you mean by separating it into smaller components by physical methods? And so when I use that phrasing, what I'm getting at is that you can't simply maybe put it through something to filter out different components. Like if you've ever used a colander when maybe you're cooking pasta, you'll separate the pasta in the water. By pouring it into a colander, the water falls through it, the pasta stays behind. Or maybe you're eating something like a salad, for example, and maybe you don't like onions. And so you can physically pull the onions out of the salad. When we're talking about pure substances, you're not going to be able to separate the pure substance by simply physically taking it apart. There has to be some sort of chemical change that would allow you to do that. Now, pure substances get broken down into two categories. We have elements and we have compounds. Now, our elements, as I mentioned previously, are those substances that are found directly on the periodic table, which is a useful tool for chemists, and they're made up of only one type of atom. And so when we start talking about matter and elements and compounds, at the smallest level, everything is made up of atoms. And so it's the smallest particle that makes up that substance that still has the same properties of that individual substance. Okay? And so your elements are these things that are found directly on the periodic table. And so I've given you some examples here of elements that can be found on the periodic table. So for example, you've got H2, that's going to represent hydrogen, that's its elemental symbol. You've got O3, this is a form of oxygen called ozone. If you've taken earth science, you might remember that ozone is that layer that surrounds the earth in its atmosphere, and it helps filter out UV rays from the sun. You've got sodium, Na, it's a metal, and you've got iron, which is also a metal, that are found on the periodic table. Now, the other category of pure substances are compounds. And a compound is a substance that's made up of two or more different types of elements from our periodic table. And instead of them being just individual elements, they've actually been chemically combined. They're somehow connected in their structure so that it's now the elements no longer have the same properties that they had before. And so compounds are going to be made up of two or more different types of elements, which means they have two or more different types of atoms that make them up. Now, water, very common one, H2O. You've got CO2, which is carbon dioxide. That's what you exhale when you breathe. You've got NaCl, which is called sodium chloride, but you guys know it as table salt. And then you've got C6H12O6, which is glucose, which is a form of sugar. And so what I want you to notice within each of those, that you have two or more different elements that make up each of those different types of compounds. So these pure substances, elements, and compounds are what we have here. Now, looking at the second side, you've got mixtures. Now, mixtures are a combination of two or more pure substances that have been physically combined. So think of it as maybe you've got like salt and pepper. You can mix those two things together. Let's imagine you've got salt and pepper shakers and you're just mixing two or more pure substances, whether they're elements or compounds. You're mixing them together and they're not chemically combining. So mixtures can be physically separated into their individual components. That's what makes them unique from our pure substances and our elements and our compounds. Now, our mixtures can be broken down into two different types, as we've already seen. We've got homogeneous mixtures and we've got heterogeneous mixtures. And so let's look at homogeneous mixtures first. Homogeneous mixtures are also commonly referred to as solutions by chemists. And so your solutions are mixtures with the same composition throughout. Now, that means they look the same. They don't look like they contain different components, but there are different components that are there. Now, you've got some different examples of homogeneous mixtures. You've got salt water. So something like sodium chloride plus water, that's going to be an example of a homogeneous mixture because the salt dissolves in water. That's how you get stuff that happens in the ocean. You've got something like rubbing alcohol. If you've ever had a cut or a scrape on your leg or your elbow and you've had to use rubbing alcohol, that's a type of homogeneous mixture. Rubbing alcohol consists of isopropyl alcohol, that's this component right here, and it's mixed with water. And another very common homogeneous mixture that's important to us is air. Now, the air we breathe, it contains nitrogen, oxygen, water, and carbon dioxide. And the oxygen in the air is what our lungs need to provide oxygen to the rest of our body. Now, heterogeneous mixtures are mixtures that vary in their composition. So they're not going to look the same throughout. They're going to be visibly different. And so in all of the examples that I'm giving you, that should be pretty evident. You've got things like granite, which is a type of rock. So it's got the rock and it has the minerals that make it up. You can visibly see those different components. A salad dressing, for example, something like a vinaigrette, something that you have to shake up, it's going to have visible components that are in it. If we have like a chocolate chip cookie, which sounds really delicious right about now, you're going to see the different cookie components. You're going to see the chocolate chips. So you see those different components. And then sulfur and iron. So these are two different elements. Sulfur is a yellow powder. Iron is a black metal. But when you mix them together, you can visibly see the differences between the two. Now, these mixtures, again, what make them unique from our pure substances, that they can be physically separated and they're made up of two or more pure substances. Now, let's take a look at the different types of mixtures a little bit more in depth. So the first thing we're going to look at are solutions. Solutions are homogeneous mixtures that have tiny particles that have been distributed throughout. Now, the thing about these tiny particles is that they're so small that you're not able to see them, or they're too small to settle out or filter throughout the mixture. So when you take a look at it, something to consider, like if you've ever had to dissolve salt in water, let's say that maybe you've had a sore throat, maybe you've been sick and your throat's been irritating you, you might have heard that you can gargle or swish around in your mouth and gargle with salt water to help kind of deal with the irritation and that particular component. And so when you do that, you add the salt, you mix it, and it almost appears like the salt disappears, but that's not the case. All it's doing is dissolving in the water, and it's no longer visible. That's an example of a solution, which is a type of homogeneous mixture. And the key thing I want you to take away from this particular slide is that the particles that are mixing are so small that we don't see them and they don't filter out. Now, another type of mixture that's homogeneous are going to be colloids. Now, colloids are homogeneous mixtures that have medium-sized particles. Now, the thing about these particles, they're large enough to see, but they're not large enough to settle or filter out. And so if you've ever made Jell-O, the gelatin that's in Jell-O, like in this particular case, it's red. It's red due to the red gelatin particles that you can visibly see. Now, the next type of mixture is a suspension. And suspensions are a specific type of heterogeneous mixture. And suspensions have very large particles. And if I use this picture as an example, you can see kind of the oil that's on the top. You've got the other component down here, but you've got the kind of solid particles that you're seeing on the side. So they're large enough to where you can see them. And that if you give this enough time, right, just like this bottle is showing us, the particles are large enough that you could see them, and they would settle out to form distinct layers. And so in this bottle, you've got the oil layer that's on the top, you've got this layer here, and then you've got those solid components that are mixed throughout. But if you gave it enough time, the solids would just kind of settle to the bottom. Now, in order for us to kind of break down how do we know if something's a colloid versus a solution, is using what's known as the Tendal Effect. Now, the Tendal Effect can be described as the scattering of visible light by those colloidal particles, or by those particles that are inside. That's called the Tendal Effect. And how it works is you take a light source, like a flashlight, for example, and what's going to happen in a solution is the beam of light is going to pass through and you're not going to see it. So if you look at it, it's passing through and it doesn't appear to be that you can see the beam of light. But when you're dealing with a colloid, so even though the particles are really small, in a colloid, that beam of light is actually going to show up in that particular container. Now, the same thing's going to happen in a suspension. It's going to hit off those particles, and that beam of light is going to be visible. And so if we wanted to make a distinction between a solution and a colloid, we're going to use the Tendal effect to do that, because in a solution, the beam of light is not going to bounce off the particles, and so it's not going to be visible. Whereas in a colloid, the particles are going to hit that beam of light, and it's going to start reflecting it and causing it to bounce, and you produce that light beam in the colloid. Now, as I close out this video, ladies and gentlemen, I want to thank you so much for your time. I've given you some practice here, and so I'm going to attach a Google form to this on Google Classroom, and it's going to have some of those similar questions, but I'm also going to embed these questions here, and I want you guys to classify each of the following things that I've listed here as either an element, a compound, a homogeneous mixture, or a heterogeneous mixture. Use your notes, use the video, use the slides, use them to help you answer these questions. It's okay if you get it wrong. I'm just trying to kind of get a gauge for what you understood from the video. And so you're going to be classifying the following. You've got sulfur, you've got Kool-Aid, you've got vegetable soup, and you've got nail polish remover, which is made of acetone, and I've given you the chemical formula for acetone right there. So please, go fill out that Google form. Thank you, ladies and gentlemen. I appreciate your time. Thank you so much. I look forward to seeing you guys again soon.